Hello everyone. Today I am going to explain how to perform active flow control using synthetic jet actuator. So first, this is the designer module. So first I just imported the model from CATIA where I imported uh, the airfoil coordinates, and I also designed the total geometry in that, and I imported, and then later I'm gonna split it into the required zones. That's why I just use a two sketch. One is sketch one. The sketch one is gonna be this straight line, and the other sketch gonna be this one. The sketch is exactly at the trailing edge. So this is a sketch one, and this is a sketch two, and then later, so this is the sketch two. So this is the sketch one. Sketch one is the line, and then I designed the domain. It's gonna be domain as per my research paper I did, and I just split the faces into these respecting orders. You can see this is one line, this is one line. So this gonna be the domain one. This gonna be the complete domain, and the sketch two gonna be divided into this one. This is a rectangle, the sketch two. So these are the edges, and next this gonna be the another split. So first I imported the sketch and I did this, and this is gonna be the surface one. So okay, I just created the surface from this one, as we know. So I just go to console like create. So I just created the surface using that, and I did the boolean. I did the subtract, so that the airfoil is get separated from these, from the domain one. So therefore we're gonna get this one, and it's gonna be the boolean operation, and this is a line which I use it. So this one, so this is gonna be the overall edges. So this, and I did the face split for like to divide the domain into the respective one. So these were the products of the face split. So you can see, so this gonna be the another face. So I made n number of faces so that I can give more, like more refined mesh for that. That's it. And this rotate, and I gave this parametric analysis so that later we can change the angle of attack as we require. And then after that, so this gonna be the parametric set. So this gonna be the degrees, which, so this is the p1, which initially I fixed it to 0, but later on I changed it to 0.8, like that. I changed it into 1.2. So these were, so this was the parametric analysis. Later if we change, the complete analysis gonna change automatically. And this gonna be the design model. So total we're gonna have 8 bodies, and I just off this all one, and it's showing the surface body. That's it. And I just closing this one, and then after doing this one, so I just open the mesh file. So now we need to create the mesh. So for this mesh, so I gonna use a structure mesh. Why? Because yeah, so this structure mesh gonna consist n number of cells. So it would be good if we consider structure mesh rather than unstructured mesh. Okay. It's gonna take some time for loading. Yeah, so this is my geometry. So this is the imported geometry, and then so this is the type of 2D analysis which I did. So this is the surface body. So we have six main, see, and these are the smaller bodies. Okay, so total of 8 bodies. And next, so the ground, okay. And next, so this is some meshing. So first I did the face mesh for this one, and next, and again, so face mesh, selected these faces, and for the second face mesh I selected the actuator, and I gave it as quadrilateral so that we can achieve structure mesh. And then I did edge sizing, where I selected the domain. So these domains, so this C section, yeah, this line I selected. For edge sizing I selected 4 edges, and next, and I selected the edge sizing, gonna be these here, just a sec. Edge sizing gonna be the upper, this one, selected this one, I gave it as edge sizing, and edge sizing number 3, I selected 7 edges, gonna be this one, okay, edge sizing, 5, I did this one, so which I didn't give the bias, that's it, yep. So and then I ran the mesh for all day, then I get this image, yeah, I just captured the image file because it's gonna take huge time for me to show the image by zooming, so I just capture the only the images. And next is gonna be the boundary conditions for me, inlet, outlet, and this gonna be the fluid domain as we see. So this complete is a fluid domain. The actuator inlet gonna be the bottom edge of the actuator, this one, sorry, this edge, not the surface, this edge. And next airfoil gonna be the complete structure except the actuator inlet. Every edges of the airfoil and actuator is considered as airfoil, including these edges too, except the actuator inlet and the all inlets, the all edges of the airfoil considered as airfoil. That's it. And next, so let's launch Fluent. It's gonna take some time for loading, yeah. Gonna take some time for loading. So due to the more number of cells, it's gonna take some time for loading, just few seconds. So that's it. So this is gonna be pressure based, absolute and steady case, and consider you also consider for transient, but it's gonna take more computational time. My computer like cannot handle, so that's why I just steady state. So this is gonna be this one. This is the model which I use in this one. Materials, yeah, yeah, yeah. Materials I give here. Next, boundary conditions. I'm gonna give velocity inlet and actuator velocity, and next I'm gonna show you just a sec. So yeah, I gave it as a formula, the actuator. So okay, so this is selected as actuator velocity. Okay, I gave it as 10, and next is gonna be the outlet one, and I also set up the report definitions like lift, drag, CL and CD. Why? Because these four gonna be the main factors, and this is the run calculation over there. And I just ran the analysis. So for me it took like 1 week, one entire week. So if you are interested, so if you have high computational power, then I can suggest go for transient. So in my case, so I got like I just limited to steady state. For me, my computer no longer gonna be used for the transient case. So that's why if you are interested, you can consider transient. I did transient, but I don't have sufficient amount of RAM to run it, so I just got the notification, so I just stopped the transient one. That's it. If you're gonna interested, you can consider transient. And if you need, if you have any queries regarding the transient, just comment on this video, so I can let you know which model gonna use as per the research paper. So this gonna be my graphs. It's gonna be my velocity graphs. Okay, gonna show. This is my pressure. This is my pressure velocity for these airfoil consideration. Actually, so I ran the simulation for multiple times. First, I consider only for the airfoil, plain airfoil. You see the boundary layer separation at what angle of attack, and I ran the simulation with actuator, with actuator 2. Then later I gonna then later I gonna compare the results of this both. So this for the results. So this is the parametric analysis. So for this, it nearly took me like more than 1.5 week to run this all simulation parametrically. I just give the parameters for them, so it keep running the simulations for entire 1.5 week. I still done it took like 2 weeks to run the simulation. So then we're gonna get these results. So this is a parametric analysis, and we also for this graph we need to set up this earlier, which I showed you earlier. So we need to while giving the conditions, we need to give that. So this complete is total gonna be the parametric analysis. That's it. Thank you everyone. I hope you understood and learned something new. Bye bye.